Hello beautiful people and welcome. In today's video we are going to go through the second part of the chapter 8 practice test. This part does involve using a calculator, so if you need a calculator, please go get a calculator. This will require a calculator. Alright, let's go ahead and draw the angle and then find the reference angle. This one is not part of the unit circle, so we need to break this angle apart. The easiest way to do this is this is in radians, so we want to create a full cycle, half a cycle, and a quarter cycle. And we want to do this before we attempt to draw it. Full cycle is 2 pi, half a cycle is pi, quarter is pi halves, and we're going to create common denominators with this 18. So I'm going to put a 1 underneath. This one doesn't need it, it's already a 2. I'm just going to rewrite my fraction a little bit better. And I'm going to multiply this times 9 so I can get 18. 18 here, so I can get 18, and 18 here. A full cycle will be 36 pi 18ths. Here, a half a cycle would be 18 pi 18ths, and a quarter will be 9 pi 18ths. And so I want to add up, this is with a calculator, so I'm going to pick up a calculator. I want to add up to 61. So I can start out with 36, a full cycle. And if I do 36 plus 36, I am a little bit over 61, so I don't have another cycle inside of 61. But if I did 36 plus 18, that means I'm at 54, which I have space for 54. Oops, I added 254, so I am adding 18. And I'm going to check if I can add 36 plus 18 plus a quarter. I'm a little bit over, so we have a choice to make. We can overshoot and then pull back, or we can add little by little. So if I'm at 61, I need to be at 61, and I've already done 36 and 18. That means I need 7 more. So I have a full cycle, a half a cycle, and less than a quarter. So when I draw this, we are at positive, so we're going up to the positive y's. I am at a full cycle, I am at a half a cycle, and I am less than a quarter. Now, how far do I go? I go almost to 9, but I'm at 7, so I'm about here-ish. Now, the question is asking you, after you draw the angle, what is the reference angle? The reference angle is the distance from here, which is the x-axis, to your terminal ray. We want the size of this angle right here. Now, it just so happens that we already calculated that distance traveled, and that distance traveled is 7 pi 18ths. This does not always happen. This is why we ask you to draw the reference angle, and we ask you to draw the original angle here at 61 pi 18ths. So the answer for the reference angle is 7 pi 18ths. If you can simplify, you must simplify. Moving on to question number 2, convert each degree into radians. So we're going to multiply this by pi over 180. So we have 1,020 degrees, pi over 180 degrees. Now here you can use a calculator. I'm going to cheat. I'm going to do, instead of doing 1020 divided by 180, which will give me a mixed number or a mixed fraction, I am going to instead take the reciprocal of my fraction and do 180 divided by 1020. This will give me a regular fraction, a simplified fraction, and then I'm going to flip it back. So I know I flipped my original fraction to type it into the calculator. Now from the calculator, I'm going to flip it back. So I get 17 pi thirds, and that way the calculator simplifies the fractions for me, and I don't have to do it by hand. Moving on here, we want to do a radian into degrees. So I'm going to multiply by 180 over pi. When you do this, this ends up removing your pi's, canceling those pi's out. And then again, we have 1 times 180. That's 12780 divided by 18. Let's see if that gives me something pretty. It does. So this is 710 degrees. Find a positive and negative coterminal angles for each given angle. Okay, so this is in radians, so we're going to add 2 pi. Now I'm adding 2 pi over 1. This is a full cycle. And notice that I do need common denominator. So I'm going to multiply top and bottom by 12. So that means I have negative 19 pi 12ths plus 24 pi 12ths. And so I have a negative 19 plus 24, which gives me 5 pi 12ths. This is a positive 5 pi 12, so they want a positive. We have that. Now I do need a negative, so I'm going to take this negative 19 pi 12ths. I'm now going to subtract a full cycle. Now I already converted the common denominator, this is a full cycle, into a 12. So I'm going to take my converted and I'm going to subtract. So negative 19 minus 24, and I'm at negative 43 over 12. We do need that pi in the numerator. Moving on here for degrees, we are again adding a full cycle and we are subtracting a full cycle. We want one answer that is positive, we want one answer that is negative. 60 plus 360, I get 420. You have to put the degree symbol. If you don't, it will be marked as wrong. 60 minus 360, I get a negative 300 degrees. Again, must have the degree symbol. These are considered coterminal angles. We want a positive, a negative, a positive, a negative. Moving on. Find the length of each arc. First thing you're going to do is you're going to take a look at the angle measure. The arc length and the area of the sector must be in radians. So notice that both of these, 6 and 7, are in degrees. You must convert that into radians first. So 225 degrees times pi over 180. That's 225 pi 180. Again, I'm going to flip my 180 and 225, typing that into the calculator as 180 divided by 225. The reason I do that is so the calculator can simplify my fraction for me. Then I reflip it and get, instead of 225, I now have 5 pi fourths. Then I have my formula, which is just the radius times my angle measure, my central angle, which my radius is 16, my angle is 5 pi fourths. Now this one is asking you just to find the length. We want our answers in exact format. So when you are typing this into the calculator, you're not actually typing in pi. You're typing in 16 times 5 divided by 4, and then we're going to just put pi at the end. If you're doing this on the calculator, make sure that you have parentheses around 16 and 5. So 16 times 5, close it, divided by 4 equals 20. So that means I got 20 pi. What are my units? My units are yards. So we want to add units. If you don't, that would be points removed because it would be an incomplete answer. Next one is asking for area. Again, we can't have this 240 degrees. Degrees are not allowed when it comes to length and area of a sector and arc. So we're going to multiply this by pi over 180, 240 pi over 180. Again, I'm going to cheat, and I'm going to type this in as a reciprocal into my calculator and flip it back to 4 pi thirds as my measure. Now area is equal to 1/2 your radius squared times your angle measure. We get 1/2. Notice how I'm putting 1/2 in parentheses. Radius is 15 inches squared, and then our angle measure in radians is 4 pi thirds. Again, how do you type this into the calculator? I would type this into the calculator first. So we got open 1/2, open 15 squared, close it. See if you guys can see that my light's not the best. And this gives me, again, so I'm hesitating a little bit because maybe I don't want to type this in first. So I'm going to write it out. I got 1 times 15 squared times 4 pi, all divided by 2 is in the denominator and 3 is in the denominator. Maybe that will give me a better answer. So I have 15 times 15, 15 squared, times 4, I get 900 pi over 2 times 3 is 6. Does 900 and 6 get along? They do. So we get 150 pi for our area. And then what are our units? Inches. Area is always squared, so you must have units squared for your answer. Moving on to the next one, find the value of the trig function indicated. This is the one that I mentioned in class. It always perplexes you as to what it's actually asking. When it's asking you for the value of the trig function, they're asking you for the ratio. So they're asking you when your point of view, here's my eyeball. If my point of view is theta, here's my opposite. Here's my hypotenuse. Here's my adjacent. They want to know what tangent is. Tangent is SOHCAHTOA. So we need to put an opposite over adjacent, which means that adjacent's missing. We have to use the Pythagorean theorem. The issue here is that when you write your Pythagorean theorem of a squared plus b squared equals c squared, you have to make sure to put the hypotenuse as your c. So a squared plus 7 squared is equal to 15 squared. And then continue to solve for your a value. So we get 15 squared minus 7 squared. I get a squared is equal to 176, which I don't think is going to give me a pretty value. So if I try to take the square root of 176, it doesn't work out. So that means this value right here needs to be simplified if possible. So I'm going to start with 176 and divide things like 4, which can work. But if I look at that 4, that means another 4 can go in it. So I can divide by 16. So that means that the square root of 176 can be split up into the square root of 16 times the square root of 11, which means that I can have 4 times the square root of 11 as my adjacent. And you have to simplify your radicals. This comes from semester 1 and IM2. So now that we have simplified our adjacent side, tangent of theta is opposite, which is 7, over adjacent, which is 4 times the square root of 11. This means we need to multiply top and bottom just by the square root of 11. This is not a binomial, this is a monomial. There's no addition or subtraction. So no conjugates here, just pick up the radical. So we have 7 times the square root of 11. We have 11 times 11. Both of them are inside a house, which is 121, which means I have 7 times the square root of 11, 4 times 11, and we end up getting 7 square root of 11 divided by 44. This is your answer for the ratio of tangent. Question number 9 is asking you for the angle measure. This one is already set up, so you really don't have to do anything. You just take its inverse. So the inverse of tangent, take your input and your output, switch it. You want to always make sure to use inverse notation. So that's why we have the inverse on tangent. And you're finding your angle measure, which is x. To type this into the calculator, you're going to press second. Your function is tangent, and that will give you your inverse function. Let me do that again so you can see it. Second, tangent. This is not a -1. This is inverse of your function. Okay, inverse of your function is not an exponent of -1. Open. Then we got our 2.2460. Close it. Now be careful what they are asking of you. So if they're asking you of angle measure, you want to have sure your degrees are highlighted in your calculator. This glare, is it going to work? Nope. Just make sure where my finger is, it says degree. And then let me retype this in. I have the inverse of tangent, 2.2460. And again, degree, so we need our calculator in degree mode. And we want to round to the nearest degree, which is a whole number. 65.99 is what I have. So that means my answer is 66 degrees. Moving on to the next one, it is asking you to find the indicated angle as well. This one is not telling you what to use. So step number 1, you're going to choose your SOHCAHTOA. It doesn't matter because they're giving you all 3 sides. Sometimes it does matter if all 3 sides are not given. Here's your opposite, here's your hypotenuse, here's your adjacent. So we use tangent here, so I'll do just sine. Sine of theta is equal to opposite. Let's write this out first. Opposite, which is here, and adjacent, we don't need. We need hypotenuse. SOHCAHTOA, we need hypotenuse. So that means sine of theta is equal to opposite is 80. Hypotenuse is 89. And again, we are trying to solve for the unknown input, the angle. So we're going to take inverse. So the inverse of sine, which means I'm going to switch my domain and range. 80, 89th, it goes here. And our theta goes on the outside. We are taking its inverse. Switching domain and range. So second, sine shows us our inverse function. 80 over 89. Enter, and it is asking us again to the nearest degree. So your calculator is in degree mode. And we have 64.0, so 64 degrees is our angle measure. Moving on. Find each angle measure to the nearest degree, exactly what we just did a few moments ago. This is a setup already done for you, so take the inverse. Inverse of cosine, which switch the input and output. Input is now 0.8480. And C is our output. This is our angle measure. Second, cosine is our inverse of cosine, 0.8480. Close it, enter, and I got 32 degrees as my angle measure. Find the measure of each angle indicated. Again, so many angles, maybe it's important. Hint, hint. Here's your eyeball, here's your opposite, here's your hypotenuse, here's your adjacent. Now this one, it is asking us 2 things. Round to the nearest tenth, so there are rounding. Next, it is not giving us all of the information of the triangle. We are only given the opposite, and we are only given the adjacent, which means when we have our SOHCAHTOA, there's only one of these that fits our description with our opposite and adjacent, and that is our tangent. So that means we have tangent of theta is opposite over adjacent, which means tangent of theta is equal opposite is 4, adjacent is 14. Again, what do they want? They want an angle. Angle means take the inverse, switch the input and output. The input is now 4 over 14. No, you don't need to simplify that. Why? Because we're just typing it into the calculator. So second, tangent, you have the inverse function. 4 over 14, close it, enter, and it is asking us to round to the nearest tenth. Tenth is 1 decimal place. So 1594, we want this placement, so that means we're looking at the number behind it. This is a 4, that means we're going to keep the 9. So angle measure is 15.9. What does our calculator say? Degrees. This is our answer. Moving on. Find the measure of each side indicated, round to the nearest tenth. Now we want sides versus angles. This is still your SOHCAHTOAs. SOHCAHTOA. Look at what they have. Here's your angle, here's your eyeball. This is what you're going to be looking through. This is your opposite, this is your adjacent, this is your hypotenuse. You have 2 pieces of information that are given and 1 unknown. Your adjacent is known. Your x, your hypotenuse, is unknown. So that means for this one, we're using an adjacent and a hypotenuse, which means you're using your cosine function. Cosine of theta is adjacent over hypotenuse, which means cosine. We do know what our theta is. I shouldn't have done that. That was, oh goodness, 48 degrees. Equals adjacent is 8, hypotenuse is x. Okay, what you're going to do is you're going to multiply both sides by x. Your x's go away. X times cosine of 48 is equal to 8. This cosine of 48 is one value. This equals to just a number. Okay, so that equals to a number. And that number, let me try to shift my cameras around so you guys can see it better. And that number, whatever that number is, you're going to divide by it. So I'm going to take that cosine of 48 and divide both sides by it, which then leaves us with x. X is equal to 8 divided by cosine of 48 degrees. You pick up a calculator, you type that in. 8 divided by cosine, no extra parentheses. This is going to give you openings on its own for your 48. Enter. Round to the nearest tenth. That means we want the 9. We look at the 5. Since it is a 5, we are going to be rounding up. So that means that this becomes a 10, which means I carry the 1, and I'm at 12.0 as my x value. There are no units on the sides of the triangle, so there are no units in your answer. Moving on to 14 again. 14 is asking for a side. They are giving you the angle. They are giving you two sides. One of them is unknown. One of them is provided. This is your eyeball. This is your opposite, your hypotenuse, and your adjacent. That means that you are going to be using a specific ratio, sine, cosine, or tangent. Since I have an opposite and an adjacent, that means I'm going to be using tangent of theta is equal to opposite over adjacent. We do know what theta is. Theta is 51. That is our degree measure. Opposite was x, adjacent was 9. Here we multiply by 9 both sides, and we're already isolating our x, so all we have to do now is type this into the calculator. 9 times tangent of 51 degrees. Press enter, and we're done with that question. 9 times tangent of 51 degrees. Make sure your calculator is in degree mode. And again, it's asking us to round to the nearest tenth. We want this one, we look at the next one. Since it is a 1, it's 11.1. There are no units. This is the answer. Next one, use the given point on the terminal value to find sine. Now on the test I am asking you to find sine, cosine, and tangent. What you're going to do is you're going to drag this down. You're going to create a right triangle. Immediately show me where you have the right angle and where your eyeball, your theta, is. Your distance up is your y value. Your distance over is your x value. You're going to use a calculator to solve for your hypotenuse. For a question like this, you're always going to solve for a hypotenuse. So you have 6 squared, a squared, plus 17 squared, b squared, equals c squared. Type this into the calculator exactly how you see it. Open 6 squared plus open 17 squared equals 325. Sometimes this will give you a pretty value, sometimes it won't. Let's take a look. 325. Nope. That means we have to go in and see if we can figure out a good number to remove, like 25. The square root of 325 is equal to c squared. Square root of 25 times the square root of 13. That means we are simplifying to 5 root 13 for our hypotenuse. It is asking us for sine of theta, but I am going to do cosine as well and tangent. Sine of theta is, let's go ahead and here's our eyeball. Remember, this is our opposite, this is our adjacent, this is our hypotenuse. So opposite is 13. Is that what it is? No, 17. Opposite is 17. I'm trying to find a pen on the side here. Give me a quick second. Thank you so much for your patience. Opposite is 17. Hypotenuse is 5 root 13. And again, we do need to rationalize. This is not a binomial. We do not need conjugates. All you got to do is multiply just by the radical. 17 root 13 over 5 times 13 square rooted is just 13. This is a calculator question. Type in 5 times 13. We get 17 root 13 over 65. Okay, don't forget to rationalize the denominator. This is sine of theta, so we don't forget. Cosine, we have 17 as opposite, so 6 is our adjacent. We still have 5 root 13. Again, how do we rationalize? Take that 13 square rooted, multiply top and bottom. We got 6 root 13. We got 5, 13 square rooted is 13. 5 times 13 is again 65. We get 6 root 13 over 65 as our answer. Now I'm double checking 6 and 65. See if that simplifies, and it does not. If these numbers simplify outside of the radical, you have to simplify them. This was our cosine of theta. Cosine of theta. All right, almost at the end, beautiful people. Graphing. We did 2 questions on graphing, sine and cosine. This one is giving you both signs. One of them should have said cosine. It is a hiccup on my part. I am going to ask you to graph sine and cosine, and I am going to ask you to write the equation of sine and cosine. So please make sure you have that understanding for your exam. Let's go ahead, and I'm going to do this on a separate sheet of paper just because it's going to give me more space. Question number 16. We have y is equal to negative 2 plus 3 sine of 4 times theta plus 2 pi thirds. This is where the computer places sometimes your k value in the front. So instead, go ahead and put that in the back. And I'm also going to rewrite this in the form of x. So here's our k in the back. Step number 1, we're going to factor out b. B is the number in front of x. And the trick with b is you're going to multiply this value right here by its reciprocal. So if b is 4, the reciprocal of 4 is 1/3. Sorry. It's been a long day. All right. 2 pi thirds, the reciprocal of 4 is 1/4. That is what I'm going to be multiplying by. So I get 2 pi. 4 times 3 is 12. Simplify that, I get pi 6. So when I do that, I'm going to rewrite and recreate an equation that I'm going to use. Y equals 3 times, that is very difficult to see. Let's find a different color. Y is equal to 3 times sine of, b was 4, remove it. X, this value right here, is going to go in the h location. That's going to be our start value. We still have our minus 2. This right here is what we want to graph. See, it's a darker color. Okay, 3 absolute valued is our amplitude. That is the distance above and below our midline. Sine is going to be an increasing function going up. B is 4 is going to be used to solve for our period, which is going to be a 1 pi 4. This is period. This h value that we found is going to be opposite of what we see. This is our start, and our start is negative pi 6. Our k value is our midline. The technically two pieces of information that are not provided by the equation is your end value and your distance between your x's. So for our end value, we are going to be taking our period adding to that our start value, and that's equaling our end value. Our period is pi fourths. I'm going to add to that our start value of pi negative sixths, and then common denominators. So I'm going to multiply here by 3, here by 2, to get a common denominator of 12. So that means 3 minus 2 is 1 pi 12th. This is our end. Here's our start. Here's our end. Immediately I'm noticing these are not the same denominator, so I will know at the very last step before actually graphing, I will create common denominators. Next one is going to be our distance between the x values. And that is when you take your period, your new period, and then you're going to multiply that by 1/4. And this is always by 1/4 because we're cutting it into 4 chunks, giving us 5 total x values. We have period, what was our period? Pi fourths times 1/4. Let me color code that because I feel like that's going to get lost. Your period is pi fourths, and then the 1/4 is always 1/4. So we get pi 16ths as our distance. This is going to be interesting. And the reason I make that comment is because if you take a look, our period is pi. Oh, that's why. Do you guys see it? I was looking at our denominators of 16 and 12, and something was going to be very wrong. So I take a look at my period, and I notice my period is off, because I simplified 2 pi fourths into pi fourths, which is wrong. This is going to be changed. See what happens when you work quickly? Let's take our time, beautiful people. So let's go ahead and change that to pi halves as soon as that dries. This will be a 2. So let's change all of this. This is all going to be different. I apologize. It's been a long day. Okay, so our distance is going to be different too because our period is going to be different as well. I think I have somewhere a whiteout. I do. That doesn't require time to dry. Okay, so our period is going to be different. Is it going to work? Yes, it is. This is going to be different. This is going to, let's see if it's going to work. There it is. All right, let's fix our mistakes. Ours, I mean mine. 2 goes into 2 once, 2 goes into 4 twice. So this is now a pi halves for our period. Our period is pi halves. That means I only need to create common denominators with the 6. I still need to multiply by 3. So 3 pi 6 plus a negative pi 6 is 2 pi 6. 2 goes into 2 once. 2 goes into 6 3 times. This is my end. Which then is going to change our distance. My period was pi halves. Let's change that. And again, I apologize for the mistakes. Things happen. I am a human. And we're going to multiply this straight across. Pi eighths. Still interesting, but nothing we can't handle. We have a start value of negative pi sixths. We have an end value at pi thirds, and we have a distance at pi eighths. I'm thinking our common denominator is going to be 24 since we have a common 8, 3, and start. So let's do common denominators. Our start, oh, you can't see that, I apologize. Our start, where was our start? Opposite of what we see, negative pi sixths. Our end was pi halves plus negative pi sixths. Common denominators, I'm saying this out loud just to double check my work. Minus 1 gives me 2/6. So I can technically write a 2 pi 6 here, but I'm just going to do pi thirds. And then distance was at pi halves for our period. And then convert that to common denominator. So let's go ahead and multiply things. I'm going to multiply here by 4 to get 24. I'm going to multiply here by 8 to get a denominator of 24. And here I'm going to multiply by 3 to get a denominator of 24. Okay, let's graph. Start value is negative, end value is positive, so I will need negatives and positives on my x-axis. My midline is at -2 with an amplitude of 3, so a little bit more on the negatives than on the positives for my graphing. So I'm going to make this positive a little bit shorter. Our start value is at -4, so I'll make that -4 pi 24ths here. And then if this is 4, my end is at 8, so 8 should be around here. Distance is 3, so if I take -4 at 3, I'm at -pi 24ths. 1, 2, 3, I'm at 2 pi 24ths. Add another 3, I'm at 5 pi 24ths. Add another 3, and I should be at 8. 5, 6, 7, 8, and I am. 1, 2, 3, 4, 5 total x values. That means my start value is here. That means my end value is here. That means that we are at a midline. Where's our midline? At -2. 1, 2, -2, midline. Amplitude is 3. 1, 2, 3 is our maximum at +1. 1, 2, 3 minimum. So -2, -3, -4, -5 is our minimum. What kind of function do we have? We have a sine function, sine wave, that is positive here. Again, we're looking in front of that amplitude value, not this k. This k has been moved. 3 positive, so we are going to start, middle, and end on our midline for our sine wave. Since it is positive, this quarter we're going to go up to our maximum, and this quarter we're going to go down to our minimum. Smooth curves, no sharp edges. You give me a sharp edge, I take points off. Beautiful people, before we end this video, I do want to go back and make sure that we simplify our fractions. Simplifying our fractions is required. So we have 5/24 that does not simplify, -pi 24 that does not simplify, but if we take a look at our other fractions, they all simplify. 4 and 24, that gives me -pi 6. 2 and 24, that gives me pi 12. Pi 12. And then 8 and 24 gives me pi thirds. So on the test, if you do not simplify your fractions, points will be deducted. You are in Integrated Math 3, so simplify your fractions. Thank you so much for your time, and thank you for watching. Bye!